Hi, Vish. Good morning. So, in the last session, we started with the spanning tree protocol, and we have seen about the spanning tree protocol that what it is used for. So, it is used to avoid layer 2 loops, right? Then, without loop, we considered a scenario, okay, that we have three switches which are connected to each other, correct? Then, we consider that what if there is a broadcast traffic because unicast traffic switches will forward very properly. But what about the broadcast? So, if there is a broadcast traffic, let's consider there is a half message. So, what will happen? It will cause two loops, one in the clockwise direction, another one in the anti-clockwise direction. Correct? So to avoid those loops, what we have to do, we have to use the STP protocol or the STP has been designed. Okay, so with the help of STP, what happens? STP is going to block a link, right? It's going to block a link. So once it blocks a link, this will be kind of scenario. So how does it make the blocking decision? So for blocking decision, it makes some elections like root bridge election, then root port election, designated port election, and alternating port election. Correct. So your spanning tree enables switches to become aware of each other. Now your STP switches they communicate with each other, right? How they will exchange what BPDU messages, right? They are going to exchange BPDU messages. Correct. So what is a BPDU? BPDU stands for Bridge Protocol Data Unit, and the BPDUs are of two types. One is the configuration BPDU, and another one is the TCN BPDU, topology change notification BPDU. Okay, so the configuration BPDU. Okay, the configuration BPDU holds a lot of information. This is the normal BPDU that is used for communication. Why TCN BPDU is only used to notify that okay there has been a change in the STP topology. Maybe a link has goes down, a link has come up. Okay, so this defines the change in the STP topology, right? Then another thing we have inside the BPDU. So inside the BPDU, we have information about bridge ID, right? So what is the bridge ID? It's a combination of priority and MAC address. And the default priority is what? 32768. Okay. And for these calculations, for these elections, like for electing the root ports, we are also going to require the STP course. So there are two methods. One is the short mode and second one is the long mode. Short mode is the original mode, okay, which is used for, speeds up to like you can say 10 Gbps. While so long mode is used for high speed connections. Okay, like you can see 20 Gbps, 100 Gbps, 1 Tbps, and 10 Tbps. Yeah. Okay. So which is the original mode? Your short mode is the original mode. Okay. Then after the switches, they will perform first thing what? Root bridge election. So how root bridge will be elected? So first they will check the least priority, and second one they will check what? Least MAC address. If priority is a tie, they will use MAC address as a tiebreaker. Okay. So initially when they are exchanging the BPDUs, every switch will consider itself as a root bridge. Every switch will consider itself as a root bridge. Then once they exchange these BPDUs, okay, so what is going to happen? They will know that okay, who has the least MAC address or least priority, and then they will update the root bridge ID. This field they will update. Then everybody will inform that okay, this guy is the root bridge. Yeah. Once the root bridge has been elected, then root port election will be there, right? So how the root ports will be elected? First of all, these are found on non-root bridge switches only. Then least cost path to the root bridge. These are what? Least cost, the interface through which there is the least cost to the root bridge. Okay, and they are always in the forwarding state. So that means these two switches, switch 2 and switch 3, they will try to check for root port. So they will find out the cost and they will see that okay, for switch 2, Z0 by 0 is the least cost, and for switch 3, Z0 by 1 is the least cost interface. So this interface will be root port, and here this interface will be root port. Then we have designated port election. So designated ports can be found on the root bridge also and non-root bridge also, right? And these are the ports which are directly connected to the root ports. Okay, so we can see port that is directly connected to the root port is designated port. This port is directly connected to the root port, so this is designated. So we can also say all ports of the root bridge are what designated. This is my root bridge, and both the ports are what designated ports. And your designated ports, they are always in the forwarding state. And also we know that each link is going to have a designated port. So we have a designated port on this link and this link, but we also require a designated port on this link. So how designated port will be elected here in this case? So first of all, they will check the cost. So both sides the cost is equal. For switch 2 also cost is 8, switch 3 also cost is 8. So this cost is equal, right? Then after, they are going to use what? So once cost is a tie, they will use the bridge ID. Bridge ID means first they will check the priority. Priority is also same. Then they will check the MAC address. So MAC address is lower. So this guy became a designated port. And all the ports which are not the designated port, not the root ports, they are what? Alternating ports. And these are the ports which will be blocked. Okay. And this will be the logical representation once STP has blocked. So whatever the ARP message was there, that will be flooded to switch 2 and switch 3. But the switch 2 and switch 3, they will not be able to exchange this message. Yeah. Then we have the port states, which is about disable, blocking, listening, learning, and forwarding. So disable means your port is down. Blocking means port is up, but it's not forwarding any traffic. Okay. Then listening state is there. In listening state, again, the port is not forwarding any traffic. It is kind of similar to the blocking state only. Okay, where BPDUs are allowed and nothing else is allowed. Then learning is there, where BPDU as well as MAC address learning is allowed. Data forwarding is not there. And forwarding state, in this state, BPDUs are also exchanged. MAC address learning is also there. Data is also forwarded. Then we have broken. So if the port has a problem, then the state will be what? Broken. Otherwise, it will be one of these 5. Yeah. This is in short explanation. The amount of time a switch port spends in each state. So disabled is the permanent state. The port is down, right? Then forwarding state is a permanent state. The port is up and forwarding the traffic. So the transition states are what? Blocking, listening, and learning. Okay. And in this case, once the STP is completely, STP topology has been completely designed. So this state here, this is also a stable state. This blocking state, this is a stable state. But when it is transitioning, that time in blocking state, it will remain for 20 seconds. Listening state, it will remain for 15, and learning, it will remain for 15. So overall, total time that it will take is what? 50 seconds. Okay. STP timers. So we have 3 timers: max is, hello time, and power delay time. Okay. So hello time, how frequently the BPDUs will be sent? Every 2 seconds. Max is how long a switch port will wait before a BPDU has been received. So 20 seconds. Then power delay time. So how much time your port will spend in the listening as well as learning state. So by default it is 15 seconds. Okay, then we discussed about the protocols. So we have open standard protocols and Cisco proprietary protocols. Okay, so in open standard we have STP, RSTP, and MST. The IEEE code is 802.1D, W, and S. Okay, so STP, it takes 50 seconds of time, and there's only one STP for all the VLANs, right? RSTP, so they reduce the time to 2 seconds and only one STP for all the VLANs. While MST, again 2 seconds, but this time one STP for a group of VLANs. Is that clear? Then according to Cisco, Cisco had PVST plus per VLAN spanning tree plus. So it was taking 50 seconds of time, and Cisco was from the beginning working on per VLAN system. So one STP for each VLAN. Okay. And RPVST, so they also reduce the time. These are the STP protocols. So this was the part we discussed in the last session, right? Any doubt in this part to anyone? No. Okay. So then today, let's move forward. PC and BPDU will discuss. This thing also I have to show you about P2P and P2P. Okay. Anything else? Path course selection. Not this one point here. Cisco Catalyst switches now operate in PVST plus, RSTP, and MST modes. And all three of these modes are backward compatible with 802.1 basically, which is STP. And now we'll talk about spanning tree Portfast. So what is this Portfast feature? Yes, Rajiv, for sure.
Yeah, it is easy to make the port directly into the forwarding state instead of like not in the blocking learning like that. It will directly we can change the port into forwarding.
Yeah. So Portfast is a feature that is enabled for what? For the end host. Okay, so whenever you want to connect end host to a switch, okay, you don't want that, okay, that port should be going through all the transitions and it should wait for 50 seconds. Okay, so you enable port fast on those ports. And once you enable port fast, the port directly goes to the forwarding state. From disable directly forwarding. It doesn't go to listening learning, right? So you can say it is a feature of spanning tree that allows a port to transition directly to forwarding state. Okay. STP Portfast is configured on the ports where end hosts are connected. Okay. This will be configured on the ports where end hosts are connected. How do you configure it? So you will say interface name, and spanning tree port pass. Okay, this is for a access. If you are configuring on a trunk, interface, interface name, spanning tree, port pass, trunk. This is it. Okay. 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 So I'll wipe all these notes. And let's say on the switch 3, I'll connect a node here. Okay. Now, since this is EVNG, so once this port will come up, right, automatically after some time it will go to the forwarding state also. Okay. So what I'll do for this reason, I'll just shut down and then no shutdown. Okay. This particular port we will shut down and no shutdown.
But in real time, that will not happen, right?
What is
In a real physical switch?
that was the same thing, right?
Okay.
Yeah, because see, what I'm trying to say is by the time I'll be able to execute the command, the 50-second time will already pass.
Okay.
Okay. So that's
Okay.
shutdown and no shutdown to show you again clearly. Okay, so let's check for Z0 by 2. So spanning tree. So you can see Z0 by 2 already in the forwarding state. Okay. So what I'll do is interface Z0 range Z0 by 3 and Z1 by 3. Okay, so that we don't see all these interfaces. To show spanning tree. Okay. Now see here. Interface gig 0/2. Now my PC is connected on Z0/2 only, you can see here. So if I say shutdown and no shutdown, and now if I go and check show spanning tree, so you can see right now it is in the listening state. Listening state. Now learning state. So it's going through the listening and learning state, right? See here. Now it is in the forwarding state. Okay. So sure. Guys, please wait for a moment. So now we will just configure Portfast on this interface and we will see that this interface will directly move to the forwarding state. Okay. So right now, if I check, do show spanning tree. So it is in the forwarding state. Now interface gig 0/2. Then we will say spanning tree Portfast. Okay. And then I'll say shut down the interface and then no shut down the interface. Do show spanning tree. And you see directly in the forwarding state. Clear? Right? Online people clear?
Yes, sir.
All right. And once you configure Portfast, do you see the mode changes to point edge? And the remaining is what? Point to point. So what does it mean? The type point to point and point to point edge, right? See here. Note this down. What does it mean? So point to point means it's connected to any other network device, maybe a PC or a switch. while point-to-point edge means Portfast is enabled on the interface. Okay. Then we have point-to-point edge. Simply means Portfast is enabled on the port. Audible? Sure. No. Noise is too much. See, once you have enabled Portfast, right? Once you have enabled Portfast, the port will not go to listening and learning state. Once you have enabled Portfast, the port is not going to go to listening and learning state. Directly it will go to forwarding state. So kind of you can say it is not going to check for the BPDUs. Okay, kind of you can say STP is disabled. Okay, now there is a problem here. What is the problem? Let's consider that this is a topology. Consider this is a topology. And I have a host connected here. Okay. This is a PC connected here. And this is connected on, let's say, for example, Z0 by 2 interface. Right? So now this is a port where PC is connected. So what I'll do, I'll just go and configure here Portfast. So I have configured Portfast here on this interface. So once I have configured Portfast, now this port is not going to check for, like this port is not going to go to listening and learning state. Directly it will go to the forwarding state. Right? Now there are two possibilities. Okay. Might be that this guy wants to use his own PC, maybe personal laptop. So what this guy will do, this guy will just bring a small switch. Okay. And he will add that switch into the network. Okay. This is what? Unauthorized switch. So this guy added an extra switch into the network. Now imagine this switch has lower priority or lower MAC address. What will happen? This guy will become root bush. Your entire STP topology, blocking ports, root port, designated port, everything will change. That should not happen. That should not happen. Another ways might be possible that, okay, this guy, what he did, that he just connected two ports with this switch. And that might cause a loop because you have enabled Portfast on these interfaces. You have enabled Portfast on these interfaces. So might be possible that okay, too much noise. So might be possible that due to these two links, there will be a loop. And we want to avoid the loop. So to avoid such kind of scenarios that, anybody connecting, because if Portfast is not there, the port will go to, blocking, listening, learning, and all the elections will happen, right? So if two links are connected, the port will get blocked, right? But if Portfast has been enabled, then there can be issues, correct? So to avoid this, now why the topology will change? Why this guy will become a root base? Because this switch is going to send what? BPDUs. This switch is going to send BPDUs here, right? So we want to stop that BPDU. We want to stop that extra BPDU. And to stop that extra BPDU, we use what? Something called as BPDU guard. Okay. We use what? BPDU guard. Okay. Now what is BPDU guard? What is BPDU guard? Monitors the incoming BPDU. Okay. So STP Portfast. STP Portfast disable the topology notification generation. That means the TCN will be disabled and will cause access port that come up to bypass the learning and listening state and enter the forwarding state immediately, right? If BPD is received on the Portfast enable port, the Portfast functionality is removed from that port. Okay. Now, how do you enable it? We say spanning tree Portfast, or we can say spanning tree Portfast default in the global configuration mode. Okay. That will do what? That will by default enable Portfast on all the interfaces. This is per interface, this is globally, and this is for run. Okay. And then if you want to disable Portfast feature, we can use the spanning tree Portfast disable command. Okay.
Sir, globally means either for access and trunk port.
Globally means on all the switches. Even if you are using trunk port, right? So on trunk port, you can enable only where you have a single host connected. Okay.
Okay.
Yeah. The condition is only where the single host is connected.
Okay, sir.
Hmm? So whenever the unauthorized sender BPDU, automatically that Portfast will be correct. But if a single link is there, Portfast will get disabled. But what if the priority and MAC address is less? Still, STP will change the topology, right? And we won't we don't want that topology to change. Okay. Because any change in the STP topology is not really a good news for the admin. This is clear? Okay. And you can see spanning tree Portfast trunk. So command used on trunk links to enable Portfast. This command should only be used with the ports connected to a single host. Okay. That disable command is for disable port. Yeah, for interface. You see here on a port. And this spanning tree Portfast default global command to enable Portfast on all the access ports. Okay. This is clear. Now, we need to discuss about BPDU guard. So what is BPDU guard? BPDU guard is going to monitor all the incoming BPDUs. It's going to monitor all the incoming BPDUs. So if a BPDU is received on a Portfast enabled interface, what the BPDU guard will do? BPDU guard will put the port in the error disable mode. It will put the port in the error disable mode. So BPDU guard is a safety mechanism that shuts down the port configured with STP Portfast upon receiving a BPDU. Okay. So this is one way to explain BPDU guard. Okay, this is one way to explain BPDU guard. This is one way. Another way to explain. This is also easy language, only that it's a safety mechanism that is going to shut down the ports configured with the STP Portfast on the upon receiving a BPDU. Or else we can say that BPDU guard is configured on, or another way we can start it is, I would say, if a port is configured with BPDU guard, it will monitor incoming BPDUs. Okay. If a BPDU is received on a BPDU guard enabled interface, it will put the port in error disabled state. It will put the port in error disabled state. I think it's better if this week we do it online. They'll keep on disturbing. Now, I think this week we should do it online. Why? Hmm? Okay. See here. So the command is if you want to use it globally, spanning tree, Portfast, BPDU guard, default. Okay. And then spanning tree, Portfast, BPDU guard, default enable or disable. And then we have show spanning tree, interface and interface ID detail if you want to see whether or not BPDU guard is enabled or not enabled. But currently don't write these comments. Why? Because I think there is a slight change. Like directly, we can also say spanning tree BPDU guard. So we will verify these comments, then only you have to note down. Okay. Now, if you want to do it globally, we can use it spanning tree. Portfast. Do you see? There is no option for BPDU guard. Right. And if I try like this, spanning tree, BPDU guard, or anything. See, global mode. I don't see here. Spanning tree, Portfast. Let's say edge. Now we have BPDU guard, right? BPDU guard and so instead of that command, note down this command for global mode. Spanning tree, Portfast, edge, BPDU guard. This is Portfast, edge, BPDU guard in default. This is the command for global. Okay. And host. You can say access ports. Okay. Got it. So this is one command. So you can say enable BPD part globally. The command is okay. This is giving highlight now. Interface name. Tomorrow notes we will have for this week online. Okay. So for interface name. Okay. Then spanning tree. Okay. And first let's check about the Portfast command. Portfast. Again, you have edge, but we don't have BPDU guard, right? But if you see here, spanning tree, Portfast, BPDU guard, that is on a specific interface, but this command is not there. Spanning tree, Portfast, if I use edge, no. If I give question mark, I don't have the BPDU guide option also. So here the command is spanning tree, BPDU guide, okay, enable. This is the command for interface. Okay, only spanning tree BPDU guide enable. This is the command. It's like seriously. Okay, let's do it practically. So what I'll do is I'll enable BPDU guard on the Z0/2 interface. Okay, then we'll not Z0/2. We already have connected a switch on Z0/0 interface. So Z0/0 I'll enable it. Interface Z0/0. First of all, spanning tree, Portfast. Okay, and let's hit enter. Okay, so Portfast is enabled. Now, spanning tree, BPDU guard enabled. Then we can verify how show spanning tree interface Z0/0. So we can see here what it says. BPDU guard is enabled. Okay, so as soon as the BPDU guard is enabled here, now what will happen? Also, Portfast is enabled on this interface. Okay. So now I'll just go and power on the switch 2. So when we will power on the switch 2, on switch 3, we should see a log that BPDU has been received on a BPDU guard enabled interface. And this will put the port in the error disable state. You see here, I have a log. Log number 1 says spanning tree, severity level is 2, action is block, and application is BPDU guard. What happened? Received BPDU on the port Z0/0 with BPDU guard enabled, and what it is doing? Disabling the port. Okay. Then second log message I have is about port going into the error disable state. BPDU guard error detected on the Z0/0, putting the Z0/0 in the error disable state. Okay. So eventually the port goes down. The port is down only for the BPDU. The port is down. Now no communication through that port. Entire communication is blocked because port is down, right? Down means what? No communication at all. Okay. These are the log messages. Okay. These are the log messages. These are the logs that we get. BPDU log logs. Now, since the port is in error disable state, okay, we can see that the port is in what? Error disable state. So there is no communication through that port. And even if you go there on the port, if I check right now, do show spanning tree. Sorry, there will be no do. If I say show spanning tree, okay, here it is not showing you anything because it was there on the Z0 by 0 interface. And Z0 by 0 interface is down right now. And if I check show interface status, see here, this is in the error disable state. Okay, this is clear. Now what if you go to the port also? Okay, interface X0/0, and if I say no shutdown, right? Check. The port will still remain in the error disable state only. The port will still remain in the error disable state. So one way is you manually shut down the port, then bring the port up. Okay, so shut down and no shutdown. See, but again, what will happen? It will receive a BPDU. Again, port will go down. This is one way. Okay. So you can say here, once the port moves to error disable state, once the port moves to, guys, what discussion is going on? Already there is a lot of noise. Once the port moves to error disable state, the port will not come up automatically. Okay. First way is to bring the port up manually. We can shut down the port and bring it up. And this is one way. So that means you'll go to the interface name, and you will say shutdown, and then you will say no shutdown. This is one way. That is going to bring it up manually. But there is also a dynamic way. So dynamically, or you can say to automatically, bring the port up, we can use error disable recovery command. We can use the error disable recovery command. Okay. See here. This is BPDU guard error recovery. So the error recovery service can be used to reactivate the ports that are the shutdown. Ports that are put to the error disable mode due to BPDU guard do not automatically restore. So we can use the following command: error disable recovery. First of all, we will mention the cause. What is the cause? It was BPDU guard. Then we can mention the interval. That okay, after how much time the port should automatically come up. Okay. So So if you want to bring the port dynamically up, we can say interface name, and then you will say error disable, or not interface. Sorry, this is not for the interface. This will be direct. Error disable recovery cause, and here you will mention BPDU guard, and then you will say error disable recovery interval, and then you will give the time in seconds. So this time will range from approximately 30 seconds to 86,400 seconds. Okay, this is what basically time in seconds, which will range from 30 to 86,400. Okay. These are the comments. Clear? In this also, it will automatically go disable if you receive the PPT. After minimum 30 seconds. Again, it will be done. See here. Right now, what happened? If I say shutdown, if I say no shutdown, it will receive a BPDU again and it will go down. See here. Receive the BPDU. But now it will not come up again until I go and shut down, no shutdown again. But what can I do? I can say okay, there is no hyphen, just remove that hyphen. Error disable, recovery, cause, BPDU. Error disable, recovery, interval, and check here. Between 30 seconds to 86,400. Now if I say 30, now after 30 seconds, it will try to bring the port up again. Again, it will go down. Then again, after 30 seconds, it will try to bring it up. You have to remove the switch. If you want that, okay, nobody should be able to connect the switch itself. So first thing is, until or unless you remove the switch, there will be no communication. That is the first case. Second case, not just BPDU guard, you will also enable port security there. So port security will not allow communication through there. So that means once the port goes down, let's say if I keep it like if I do not give the error disable recovery, the port will remain down. Now the employee who used that switch has to put up a complaint. He has to raise a ticket, right? Concern that, okay, I'm not having communication. And when we will check the switch, we will see this log and we already know what this guy done. He cannot be smart, right? And then port security. Port security will do what? As soon as this guy connects the switch, more than one MAC address, port will be down. Port security will capture the MAC address also. Okay. So after 30 seconds, you will see here. Now these logs may take some time to appear. Okay. Like I can do one thing. I'll just go and shut down the G0 by 1 interface of the switch tool. Right now it is in the error disable state. This port is down. Again, I'll give those comments. BPDU guard. Okay, it's taking some time. Hmm? To make it up, don't you want your interface to remain up? So that means the employee who has connected the switch, see here, now we got the log. Just 1 minute, guys. Okay, so you can see attempting to recover from BPDU guard, error disable state on the Z0 by 0, interface change state to up. Again, what will happen if I just say no shutdown? So as long as the switch is connected, see here, receive BPDU on the port, Z0 by 0 with BPDU guard enabled. It will again go down. After 30 seconds, it will again come up, again go down, right? So why this is happening? This is happening because somebody has connected an unauthorized switch in the network, right? Then what else you can do? You can configure these switches to forward like SNMP. Everybody remembers, right? So what we can do? We can monitor our network, and if something like this goes on, we can get an alert. Already, we can just go and keep that guy that who is doing such things, right? So as long as this, see, we want that okay, this host should have a communication. That's why we want that okay, this should remain up. Otherwise, what will happen? It will keep on reaching that we have now having communication. Then again, it will try to use a switch. This is unauthorized switch, right? This is not our organization switch. So definitely this has to be done. How many people do that?
Your voice is lagging.
Lagging? Like not clear.
You are not clear.
There is a lot of noise in the backend. Canceling my noise. This is clear, right? Parallel disabled.
Yes.
Okay. Let's keep it up till here only because again I'll discuss something and if you're not hearing it properly, there is no meaning of it. Okay. And tomorrow onwards for this week, our session will be online only. Okay. Yeah. So far there is no notification of a holiday tomorrow, so we have a session. If there is such notification, you will get information in the group. Okay.
Sir, tomorrow no, it's only online, no?
Yeah. For this week, only online.
Okay, fine.
Okay.
Sir, if you don't mind, please share the this note to the drive as well.
I think I have shared, right?
This note,
Yeah, updated. I'll share again, no problem. This is
okay,
there in the drive only. STP is there in your drive. Yesterday itself I shared.
okay, fine.
Okay.
Thank you.
All right, guys. Then I'll see you tomorrow. Have a good day.
Thank you, sir.
Okay, guys.